Welcome to Study Loop.
Okay, so for this problem, I have already started drawing it out because that's the easy way out. So first thing to note is that this is a square, its sides are equal. And here I have drawn the forces that are given. So we have three different forces acting on the square. So the center is the point where it's going to rotate around. So that's why I have divided it at the center point, because this is a square. The distance from this point here to this point, which I call here L1, is the same as the point from O to this end, the center from the other end, and vice versa here too. So the lengths here, which is L1 equals L2 equals L3, which is 0.09 meters, which I got by just dividing the number that's already given in the problem, because it's a halfway point. Okay, so once we clear that out, we have L. Now let's look at the different forces that we have. So there are different ways of approaching this, but because the text uses clockwise, counterclockwise, I'm gonna follow that. So F1, note that it's gonna go this way, which would be considered clockwise. And the standard in this textbook is to use clockwise as negative. So I'm following that rule here. And for F2, it's going to be going the other direction, which is counterclockwise. So that's going to be positive. And then for F3, it's at an angle. So I'm assuming you already know this, but for toric, the force has to be perpendicular to make any difference. It's like, when you're, I don't know, trying to open a door and, like you're pressing down on it at one arm, like it has to be the only force that matters is the one that's perpendicular. So for F3, because this is a square, typically we're only interested in one side, but because this is a square, both the X direction and Y direction, they have an impact. So, but luckily both of them actually are in kind of in the same direction. It's kind of like, think that, like this is where the center is, and then think that you have this square and you're pushing it at this angle, which means you're going to be going that way, right? Which is counterclockwise, so it's going to be positive. And I have already done some work here. So the Y direction and the X direction are going to be equal because it's a 45-degree, and sine of 45 and cosine of 45 is the same. So I have the number here. Okay, so now that we have all the forces and the lengths from the center, we can calculate the net torque. The net torque, I have simplified it here by using net torque equals the length times the net force, because the length here, the magnitude of the length is the same. So what is changing is only the force. So the forces here, we have four different forces when I break down F3 into X and Y. And I also already put in the signs for each force, the direction, right? For F1, we say that's clockwise, so it's going to be negative. F2 and F3X and F3Y, they're all counterclockwise, so they're going to be positive. So F3X and F3Y, they have the same magnitude, which we worked out here. So when I multiply this by 2, it's just going to give me square root of 2 times f3. So now that we have this formula, that all we have to do is just plug in the numbers that are already given. When you do that, the final answer you're going to get is going to be 2.5 Newton meter. Because it's positive, the number, that tells you that net torque is going to be counterclockwise. So it's the square is going to be moving in a counterclockwise direction. Okay, so that is pretty much it.